Hello there. In this video lecture, as we started with half wave rectifier and its analysis, now so many parameters we have already analyzed, and the last parameter that we are done with is transformer utilization factor, that is 28.7. Now we will discuss about its efficiency. So many books they call it as rectification efficiency, is it? If you call efficiency, yes, it's a efficiency of a rectifier, so you can call it as rectification efficiency. Now efficiency of half wave rectifier, basically what is job of rectifier? To convert AC into DC. So in between that conversion of AC into the DC, how much efficiency is it? This half wave rectifier how efficiently converts AC voltage into the DC voltage, that's what we need to find. So as if I want to find efficiency, I have to consider output parameter, I have to consider input parameter, that's what. So which parameter to consider? Output power and input power, is it? So input power means what we fed to the rectifier, it's an AC signal, so input power means AC power, and output is always DC for the rectifier. It's a pulsating DC, but we will not enter into more detail about pulsating and DC, we have discussed so many times. So output of the rectifier is DC, input is AC, so it is the ratio of DC divided by AC, that is DC power divided by AC power, is it? So we are not going to write a definition in words, that is rectifier efficiency is the ratio of output DC power delivered to the load divided by AC input power by the transformer. Yes, we are not going to write in words, directly we will write equation of efficiency as efficiency is equals to, let me write here, efficiency is equals to, it is PDC divided by PAC. Now this PDC already we have derived, is it? And that PAC also we have derived. Let me check where we have derived this, maybe in second page. Okay, it has been closed. Okay, sorry for interruption. Okay, sorry for, there was a technical problem. Suddenly that whiteboard get closed. Okay, so what we were discussing? We were discussing PDC and PAC. That PDC and PAC value already we have derived, is it? What is the equation for PDC? Let me write on here. PDC is equals to, you remember, VM divided by sorry, we have derived those PAC and PDC in the form of current, so it is instead, let me write as it is Im by pi square multiplied by RL and divided by, now what is that PAC? We have written it as Im by 2 bracket square multiplied by RL. This is what we have represented PDC and PAC in the form of current and resistance. We can represent in the form of voltage and current also. We can represent this DC and AC power in the form of voltage and resistance also, is it? As we have already chosen this format, that is current and resistance, that's why I'm using it. Whatever we have derived, I've used it, is it? Now as look at this, it will be then after simplification Im square divided by pi square multiplied by RL, Im square divided by 4 multiplied by RL. Now if I simplify this, then simply what I'm getting it is, yes, 2 square is equals to 4 divided by pi square, and what happened? Yes, it is 4 divided by pi square. If you use your calculator, put the value of pi, then you will get it is multiply by 100 will be 40%. Actually you will get 0.4. Now I have multiplied it because I want efficiency in percentage, so I'm getting 40%. So half wave rectifier has 40% efficiency. See, 40% efficiency is too less. Even transformer utilization is also very less, and that is the need to go for full wave rectifiers, center tap and bridge rectifier. Is it? So this is about efficiency. Now after that, few small parameters associated with this half wave rectifier, actually associated with all the rectifiers, we'll see after this efficiency. There is another factor which is called form factor. So let me write that form factor also here. Okay, take a new page, then write down form factor. I will write short form. Okay, let me write full form factor. The short form is FF. Now what is that form factor? Form factor is the ratio of RMS current to the DC current. So I will write it is a ratio of RMS value of a current divided by DC value of current. Now what is that RMS value of current we have calculated for half wave rectifier? Strictly it is Im divided by 2. And what is IDC we have derived? It is as Im by pi. Now what I am getting? I am getting Im will get cancelled. It will be 2 divided by pi. It means if I calculate by putting value of pi, it will be 1.57. This is form factor, is it? And when form factor is useful, actually, if you are dealing with the circuit, a half wave rectifier or any kind of rectifier, then after a ripple factor, is it? Roughly I can say the form factor represents a kind of ripple, is it? A kind of a ripple, but we have derived a ripple factor already, which is different. So that's why generally people don't include this form factor, because people get confused between form factor and ripple factor, because both having average value, sorry, RMS value and average value ratio, is it? Here also I have average RMS value and average value ratio, is it? But it is quite different, is it? That in case of ripple factor, what we have is RMS value of AC component. RMS value of AC component. Here I am considering RMS value of the complete waveform. So this is what form factor. Another small parameter which generally associate with a rectifier is peak factor. Let me write that peak factor also. Peak factor. See, as I have started with those very small parameters, it means we are about to finish the analysis of half wave rectifier. It's quite good news. See, if you count, we gone more than 10 parameters we have derived. This is, I don't remember the number, but we crossed 10. Now what is it? Form factor? It is a ratio. I am not going to write a definition. Clearly I will write equation directly. It is a ratio of maximum value, or I can say peak value, to the RMS value, is it? So let me write it is now here form factor we have written in the form of current. Here I will use a voltage. I will use, okay, Vm divided by V RMS. See, it is a peak factor, means what is the peak voltage available, divide that peak voltage to the average, to the RMS voltage, is it? And when I explained what is RMS, that time I differentiated clearly what is peak and RMS values are different, is it? If you use CRO, you will get peak value on the CRO screen. If you use multimeter, you will get RMS value on the digital multimeter screen. That's what it is. If I take ratio, then I'm getting peak factor. Now this Vm will as it is, and this Vrms is what? Peak divided by root 2. I know that. Sorry, let me out of this Vm divided by Vm divided by root 2 instead. What I need to write is, okay, that board is not working properly. Okay, there is some problem. Okay, we'll stop here and then we'll explain this remaining things in next probably. If it gets okay, then okay, let's start with again. So where we are in peak factor. So Vm divided by V RMS, that is Vm divided by Vm divided by 2. So I am writing Vrms is equals to Vm by 2 because already we have derived the RMS value of a voltage waveform. Look at this. This voltage waveform we got. This again this from 0 to pi there is a voltage, from pi to 2 pi there is no output voltage I'm talking about. So for this waveform we have derived Vrms is equals to Vm by 2. And so that's why this Vm will get cancelled, 2 will be there, and form factor, sorry, peak factor will be 2. That's why. Form factor and peak factor, those are very small parameters related to rectifiers. The another thing is ripple frequency. Is it? As we are considering each and every small parameter related to rectifiers. We will not skip anything. Ripple factor. So RIPPL, ripple factor. People call it as R and capital. Again, I have written factor. We are supposed to write ripple frequency. Sorry. Ripple frequency. This is what ripple frequency. Now, as if look at this waveform. This waveform I'm talking about. Look at this waveform. This waveform repeat itself after every period of 2 pi. Is it? Now the frequency, ripple frequency, obviously this waveform, this curve, is this shape will repeat itself only once in a complete cycle. Look at this. This, if I'm considering this is one cycle, it means this will repeat only once. Is it? And after 2 pi again it will repeat itself once. Again after 2 pi it will repeat itself once only. Is it? So a ripple frequency, this ripple frequency will be exactly equals to line frequency, that is frequency of the input that we have applied. Right? So generally what we write ripple frequency RF is equals to F. And what is that F? F is a input frequency. F is input frequency. So whatever input frequency is the ripple frequency of half wave rectifier. Is it? So you will understand better if I draw full wave rectifier and its waveform. Now for full wave rectifier, look at this. For full wave rectifier, output waveform is this one. It means from 0 to pi, and it is 2 pi. Now between 0 to 2 pi, the signal repeat itself twice. Is it? This is first and this is, so signal repeats itself twice, and that's why for full wave rectifier, ripple frequency is 2f. Where it is now 2f for full wave rectifier. So as if in half wave rectifier it is just f. This is about ripple frequency. Now we will see another parameter, that is regulation. Is it? Let me write a regulation. Now regulation is what? How much stability is there in the output? How much stability is there in the output voltage? It means maybe voltage or current. Output voltage changes with respect to some parameters. That's what regulation is. For example, if output voltage is changing, if I change input voltage, then it's a bad regulation. Is it? Output voltage should be constant. It should not change even if I change input voltage. output voltage should be constant even if I change load current. Is it? So output voltage should be constant at anyhow. Is it? At any circumstances, this output voltage must be constant, and this defines a regulation. Is it? I will conduct a separate practical session for rectifiers, and in that session I will explain what is that regulator in detail. Is it? So here we'll conclude with this half wave rectifier analysis. After that we will start with full wave rectifier, and again we'll analyze all those 12-13 parameters. We'll calculate all those 13 parameters for full wave rectifier. Is it? And then we will turn towards one practical session. Is it? What to do in that practical session, and that session I will explain what is regulation. Okay? So next lecture I will start with full wave rectifier.